Good afternoon, everyone, and welcome to our session on machine learning approach to identify high value donors. So today we are going to talk about high value donors, and we'll talk about it from a prospecting perspective. We will have another session on identifying high value donors among existing donor base. But this is more from a prospecting perspective when you are trying to get new donors through the door. How do you get ones who have higher value of donation? How do you do all of that? And why machine learning is well suited for this exercise? Okay, little bit about us. Uh, we are a consulting and analytics data science firm based out of New Jersey, and we develop analytics solution using machine learning and AI for to help with different functions like fundraising, marketing efficiency, operations, credit risk. Um, and we serve organizations in nonprofits. We serve organizations in publishing. We do some work with financial services as well. Okay. And here are some of the organizations who have worked with us in the past. And with that, let us get into the main topic. So the first thing is, what are the approaches used by nonprofits to identify high value donors? And by no means what I will list here is comprehensive, but at least it's kind of the most common approaches that are used. So then there are and the prospect research route where you gather information on potential donors. Well, this is more you find out about their history, their interests, get to know them, cultivate a relation with them. And this is true for this approach is more relevant for when you are trying to get to specific individuals, and not so much when you are trying to say increase the average donation amount by a significant amount. Um, and then there are approaches to donor segmentation where uh, you tailor the communication and strategy and how you approach them, all of that, to different segments of donors, different groups. Some might be giving a low amount, some might be giving a higher amount, and you tailor your messaging and so on. And it's a very useful approach, the segmentation approach. Uh, And then there is, of course, the very popular and useful wealth screen. It's not very unusual for organizations to get a wealth screen on their file or their prospects, and using that, they try to identify uh, who is likely to mm, donate and give them a high value donation. And then there are events. There are some, there are certain type of events that are organized, and at that event setting, maybe donor's interest to the cause can be identified. Then there are board members who might recommend certain donors. So all of this is more on a smaller basis. It's not one to one, but it's still just focusing on a select few set of donors and trying to identify who has the capacity to mm, mm, give a high amount of donation. And this again kind of lines up with kind of the first prospect research. It's similar approach. And then there is the data science approach of analyzing past giving. We review past donations to identify patterns and trends. And that is the focus of our conversation today. How we learn from our data, use data science to identify high value donors. And I should qualify that by saying I'll be focusing on high value prospects more than donors. Mm, mm. Okay. Okay. So I will start with a case study. And using this case study, which we did with one of our clients, uh, I will bring out use that kind of as a reference to talk about how machine learning can help. So let me give you the campaign overview. This was a nonprofit runs an annual fundraising campaign using digital display ads. Eh, And it's the state where this nonprofit operates, there is a state tax credit, and the campaign involved tailored messaging towards the state tax credit, which can be obtained if you donate to the charity. And so that's kind of the key thing about the campaign. Uh, the machine learning model use past campaign and donor profile data to build the model. And it tries to identify pods of donors with different characteristics. And later on, I will reference back to this and tell you what I exactly mean. But that's what the model did. And then greater importance was given to high value donors in this exercise. That was kind of a decision we made that we wanted to try to target more high value donors. And it was kind of a champion challenger test. There were existing lists, and there was the machine learning model generated lists, and they were both used uh, for this campaign. And a little bit about the results. So I have the machine learning list on the top, and then the lookalike prospect campaign, which was being done before there. Two things, two or three things I have highlighted here. First is that in terms of the average gift amount, the machine learning model does significantly better uh, than the existing list. In terms of the conversion rate too, it does significantly better. Um, but in terms of click-through rate, the existing prospect list does better, and that's a trade-off we will be uh, talking about, and I will talk a little bit more about. But given the goal of getting high value donors, you see the average gift amount is significantly higher for the machine learning model compared to the traditional model. So is the conversion rate. So, and I will bring out why we see the results we see a little bit more. I thought it would be useful for us to have this case study in front of us as we go through the exercise where I explain to you very briefly what machine learning model is, and also talk about why you're seeing what you're seeing with the machine learning model. Okay, so a very brief introduction to machine learning. So, if you've found us through our Eventbrite page, you see we have a bunch of webinars on artificial intelligence, and they are available on our YouTube channel as well. But machine learning is a subset of artificial intelligence, AI, that focuses on the development of algorithms and statistical models with limited human interference. Sorry. So uh, it's not like it's a totally, it can be a totally machine driven solution, but a more common scenario, especially when developing the machine learning model, is there is human interaction with the model, but the deeper intricacies are left to the machine, and the human kind of guides the way through using some of the uh, higher level parameters and performance metrics. Okay. So that's, one can have sessions on what machine learning is, but that's just a kind of brief two-line definition, if you will. Okay. Then another term you will learn about, or you'll hear people talk about, is supervised learning. Now, and then another related term you hear is unsupervised learning. And since we are talking about machine learning, and though this is not going to be a technical presentation at all, there's some terms which help. Supervised learning is when you have a target you want to optimize. For example, the average donation amount in this case, or the number of donors you want to bring in. Uh, Things like that. Uh, uh, the kind of algorithms and models you'll use to solve a problem like that is called supervised learning algorithm, as opposed to an unsupervised learning where you do not necessarily have a target. You're trying to say, for example, if given my list of donors, who are the ones who look different from the flock? Or how do I group my donors into different buckets? There isn't an objective here where, except that you are looking at underlying characteristics of a set and trying to put them into different groups, for example. So that's an unsupervised learning. Uh, I said that for our exercise, supervised learning is very useful. And we are focusing in this presentation on prospects and how to get high value donor among prospects. But a lot of times you are looking at with your donor file, who are the donors who stand out, how are they different, and that's often a clue. For example, for very rare events, like someone gives is donates their estate giving, or very very high, they put you in a will, in their will, things like that, which are much low frequency rare events, anomaly in terms of data science. And their unsupervised learning can be a starter point. It can help you identify underlying patterns, um, which might help you in your decision as you run your nonprofit. Okay. And another term which is often used in machine learning is reinforcement learning. And that's nothing more than saying that whatever we develop, we are learning through trial and error. All of us learn through trial and error in our lives and get better at what we are doing. And the algorithm essentially does that. That's what it means. So as I talked through, I gave you applications of machine learning. Some applications would be identifying high value donors, to segment donors, then prospect models, donor timing models. We have over the course of the year webinars on all of these topics, but these are some areas which might be where machine learning can be readily applied. Okay. So the question is why machine learning helps with high value donor modeling. So first of all, there is an imbalance in the data there are fewer high value donors in general, and uh, machine learning approaches are equipped with techniques of sampling and creating balanced samples that help us tease out the characteristics of the high value donor. So that's one of the things why machine learning helps. And then machine learning also has equipped with advanced algorithms like neural networks and other algorithms as well, which are good at learning complex patterns and have greater sensitivity to rare events. So when your event is rare, like high value donations and estate giving and things like that, uh, the difference between a traditional approach and a machine learning approach kind of becomes more significant because the algorithms can do better with rare events. And then machine learning algorithms, there are a whole bunch of machine learning algorithms which are good at identifying anomalies and flagging potential rare events. And this goes back to a little bit to what I was saying in the previous slide about unsupervised learning, where there isn't a target, but you're just looking at characteristics and figuring out what stands out. And this difference allows you to maybe identify donors who will write you a really big check at some point. And that's something, again, which machine learning does very well. So another thing which I mentioned and which uh, is a tension which your campaign will have, especially at the prospects, is the trade-off between volume and of donation, like number of donors you get versus the high value donations. And that trade-off is something we need to be cognizant of. When you are doing, maybe you're in your existing donor file, you are trying to do, say, a campaign where you identify high value donors, this is going to be less of an issue because you already have your donor base there. But at the prospecting stage, this trade-off will be very, very well pronounced. And in terms of um, if you go for just volume, quantity of responses, you have maximized your reach, but you have a lower average donation amount. So that's kind of the pros and cons of the strategy where you try to maximize donations. As opposed to if you go for higher value of responses, so you try to optimize your machine learning model to go for greater average donation amount, for example, then what you do, you get a higher donation amount. Of course, you're targeting that, but you have limited your reach. And so there is this tension between, and this, there is a need to balance this trade-off. You could do, how do you solve for that? One way is, okay, you do a segmented approach where you target different audience segments. And that can be done, but there is additional complexity involved in this. It's not a bad approach, but there is additional complexity involved in it. Organizations might not have the bandwidth or the technical horsepower to pull this through and take on the additional complexity. So those are the limitations, but it is a viable approach. Alternatively, using machine learning allows you to play around with weights across different parameters, and using that, you try to create a balance. Okay, uh, if I move the needle so much further, I am getting too many high valued, I'm focusing only on high value donations, and my actual people I bring in is becoming very less. Maybe I move the needle down a little bit and I still get some high value donors. I get a reasonable amount of high value donors, but I do not give up on my base donors. And so these kind of trade-offs can be done using different weighting techniques within your machine learning approach. And the key thing I want to emphasize here is there is no one, hard line you draw and then you have to follow it. Any campaign, and especially driven by data science and machine learning, there has to be a learning feedback. As you learn, you understand what you did better, and that incorporate that process in your learning to get to a superior result. So that feedback loop is very important. And I said that machine learning, I talked about why machine learning is better at uh, identifying some of these rare events or identifying high value donors. And I wanted to talk to you a little bit more about that. So, um, you see these blue dots on my screen. It's a very simplistic way of representing, say, this is your donor base. Okay. And then when you build a traditional model, say it's usually some kind of linear model, what you are doing is essentially you are drawing a straight line, an average through this population. And this average kind of presents your typical um, uh, donor, and it tries to pull in people. If you had a model like this, what it will do is all the dots that are around this line, they are the ones that get pulled into the model. And uh, so this is like the traditional approach. It's driven by single equation in most cases, and it tries to. It's a very good approach, and it gets you the average donor and gets them to you in significant quantity. But then once as you do that, uh, as you can see, there are donors lying which are very far away from that average line. In this, there are a lot of blue dots which are very far away, and those are likely to be not picked up by this linear representation. For example, this one I just highlighted, this will be missed by the model. So that's kind of the challenge, and that is why a traditional approach, a traditional model often is not very good for a situation where you are trying to get these off the average path mm, mm, instances and want to capture them. And so now let us look at it again. What a machine learning model will do is, uh, and especially we take kind of an pods approach to machine learning, um, mm, and you are essentially creating pockets or pods of donors around, and and the choice is between the pods rather than that one single line. So because you have created these different pods of donors, and then you are trying to select pods based on their marginal value when you're compiling that list, diversity in more or between characteristics that define response and the donation are going to be captured much better. The donors who are here on the top left are going to be much different than the donors that are here on the top right, and that's and those both have a chance of making the model, because you have localized a lot of the characteristics and are picking up those local groups when you are creating your campaign list. So that is why the machine learning model can get high value donors as well as your average donors both on the list. It is possible, but at the same time, it would be incorrect to say that trade-off doesn't exist. The trade-off exists, but it is less an issue than in the traditional approach. So I hope I gave you some idea about why the machine learning approach does better. So this is all well and good. And a fair question here would be that, okay, we are all interested in doing machine learning to identify high value donors, but it seems like how does a mid-size or a smaller nonprofit muster the resources and the funding to do something like that? And we have an upcoming webinar on cloud technologies and how cost effective it has become to deploy machine learning models using some of these cloud platforms. This webinar, if I'm not mistaken, is on February 12th. So please feel free to go and sign up for it on our Eventbrite page, and we would love to have you there. But uh, uh, I will give you a little bit of schematic of how you could deploy the machine learning model, how could develop and deploy all of it, just to give you an idea. And we'll have a whole session on this in February. So first is always is data preparation, collection, and process data from CRM. So you might be on Salesforce, for example, and we would need to extract the data from there um, mm, to get it and prepare it for the model development task. Then there is the model training. This is the step where models can be built, needs to be built. And there are, and this is where it could become overwhelming for an organization because they might not have the infrastructure to build the model. Well, um, you could use an organization like us to build that model, and this model can be built within our environment. But there are a lot of automated or semi-automated, still needs to be guided for it to be intelligent, but automated systems now available on the cloud, which can help you um, build the models without a lot of background in data science. Obviously, having knowledge of data science, you can choose the right parameters, get it better, and so on. One such, some of the popular cloud technologies out there, like Amazon's AWS, Google Cloud, Azure, they all have some solutions around that. Vertex AI is a Google solution we use with a lot of our clients as well. So over there, there are automated ways in which you can build uh, a model. Obviously, having a data scientist look at it and do it, there is going to be additional finesse and additional performance, but it's a very good way to get started, and often that might be enough. Um, And then the model has to be evaluated. You want to make sure the model is performing well. It is usually people have holdout samples and then they test it, and then there is test campaigns done and all that, depending on level of comfort and speed to production needed. Model evaluation needs to be done. And then the model needs to be deployed in the cloud platform. And again, there, deployment need not be on cloud platform. It can be within the organization's own infrastructure. But where you want to have low overhead, it is very easy now to deploy a machine learning model on a cloud platform where it is available, and then you just need to when a new file becomes available, it gets automatically scored. The model automatically scores that file, or based on your use case, there might be someone might need to click a button, but that process can be automated depending on different parameters and requirements. And then the file gets posted to a certain bucket or folder from where the team can just download it and use it. It is also possible to populate the results of that scoring into some kind of a dashboard with just a few clicks. And it is possible to integrate it with existing CRMs, which might need a little bit more work, but again, not um, mm, fairly easy to accomplish. And then once the model is deployed, we predict with the model and then monitor the model. Monitoring is where you look campaign to campaign, you look for performance metrics, you might look at inputs, what the model is using, all of that, and make sure those inputs are relevant, continue to be relevant. The model is doing, it's continuing to give you the results it was giving. All of that it makes for the deployment schematic for this machine learning model. And once the data is extracted, everything from model training, evaluation, deployment, monitoring, all of this can be done on the in a cloud platform now. So with one-time help with someone from just setting you up there, it is very much possible without having your own internal data science team to just have all this on in your as a tool for to help you with your fundraising. So I hope you found all of this useful. Please feel free to join our upcoming webinars. We have a whole bunch of them